because we were still working on the beginning of all these packets, because there were like a lot of them, and we didn't actually get this far.
That's reasonable, but I still don't like it. All right.
Oh yeah, we also have the review packet.
That's true. Okay, how do we do this? How do we do this? Give me an idea. Who has an idea? Yell.
Like cosine 2x is
Yep, stop. Good. I like everything about that. Yeah, cosine 2x is stop, she says. What is cosine 2x?
well, like 1 minus 2 sine squared.
Yeah, this is a fact. This is a fact of life. Do you agree?
You have like sine squared.
Right, does everyone agree? Yeah. Okay, go. Using the fact that cosine 2x is 1 minus 2 sine squared x, please solve for sine squared. Please, like, do that.
How would you think to do that? I don't.
Because you don't know any other identities.
Packet is posted online.
You don't know any other identities involving sine squared except for that one.
No, I'm not.
No, yeah, we're talking there.
Bam. That is the so-called, Mateo, that is the so-called power reducing formula for sine squared. You did that with Giles a long time ago. It was a stepping stone on the way to the half angle formulas. Suddenly coming in handy now for this anti-differentiation problem, because if I convert sine squared into this, 1 minus cosine x over 2 dx, cosine 2x, then suddenly I know how to do this, right? Because it's just that minus that. Finish it off. Okay, let's do something else. How about what else is on that page?
Number 30.
30. What's 30? Oh, how about 29? 29 looks hard. Alice, did you figure that out because it was in the book? Or someone just told you? Or what happened?
Wait, what?
29.
I didn't do
I'm looking at a paper with...
this. That's hers.
Oh, that's hers. How did you figure this out? Someone told you? Or was it in the book? Or you figured it out? Got help. It was in the book. Okay, so there are 2 ways to do this. There's the like kind of cheap way, and then there's like the cool way. I think we only have time for the cheap way now. So what's the cheap way? The cheap way is there's like a thing that you never would have thought of in a million years.
Yeah,
What's
that's
something else?
what I was asking.
Yeah. So here's the cheap way. The cheap way says you just do the obvious thing, which is to multiply the top and bottom by secant x plus tan x.
If I see one of these on the test.
That's definitely the obvious.
Why do we do such a thing?
Question.
Yeah, so this becomes on the top, I get secant squared x plus secant x tan x over secant x plus tan x. Okay, that just looks like a terrible mess, except it's great, because what is secant squared after all? The derivative of tan. What's the derivative of secant tan? So does it look like someone did some chain rule here? Maybe.
I don't even know.
Yeah, what should I let you be?
Secant x plus tan x.
Yeah, if I let u be that denominator, then du is, you know, secant x tan x plus secant squared x. In other words, exactly the numerator. What?
Do you expect us to be able to just like do that?
So this is du over u. Answer?
ln absolute value of secant x plus tan x plus b.
So this is ln absolute value secant x plus tan x plus c. That's pretty awesome. Okay, do you want to see the cool way in like 1 minute?
Yeah.
Or I'll start the cool way and you can finish on your own. The cool way is but it's like harder, is to write this as 1 over cosine. And then you have to kind of try some crap. Can anyone think of some crap that we might try? It's actually pretty close to being a good idea. He says multiply by sine over sine, but then I don't like sine cosine, like I don't want that.
Cosine. Multiply, divide by.
Yeah, multiply by cosine over cosine. That looks kind of promising because now What makes that look promising? Keenan.
Like, then when you differentiate that, like, the powers are in cosine.
When you differentiate, you get like 2 cosine.
Yeah,
If you
yeah.
set u equal to the bottom, then you differentiate, you get like 2 cosine, and that's like on the top.
No, you get 2 cosine sine, back inside negative sine. Thank you, yeah. Yeah, this is cosine x dx, and on the bottom, cosine squared can be written as 1 minus sine squared. Okay, why is that good? Give me a u, whole class.
Sine x.
Yes, let u be sine x, the du is cosine x dx. So I've now successfully converted this into yeah, du over 1 minus u squared. Alright, now the question is, the problem is that though that looks beautiful, I don't know how to do that either. Neither do you. But there is a way. Can anyone think of a way to do this? Reach back into the deep recesses of the full range of your algebra skills. Remember sometime like forever ago when I taught you about the way to like take complicated things and make them into smaller bits and pieces of things.
Oh, you don't mean that thing what we did with the fractions, right?
I do mean exactly that.
Wait, what?
No, it's important. I swear it's.
Yeah, so this is like 1 over 1 minus u, 1 plus u, du. And then, yeah, I mean that thing with the fractions. Partial fraction
Oh,
decomposition.
I literally hate that.
Yes.
So
Off to the side, we say 1 over 1 minus u squared is a over 1 minus u plus b over 1 plus u. And then, like, math happens, and that's going to split it up into, like, 2 little fractions, right? Each of which are then deal with the bowl. Do you agree?
Yep.
Because, okay, so I'm going to let you finish this on your own. Please explore the joy of self-discovery.
You're supposed to recall
I finished
partial
story.
fractions. I don't understand.
No, it's not.
Let me think about it. You see,
You have
and
to.
there's like
Recall.
partial fractions. Maybe that's what I should use. It's a
Good.
clear hint, isn't it?
Good. So please, like, do that out and confirm that you get the same formula as above, which is nothing. Okay, more.
I think secant.
Let's do one more problem.
Can we go back to the wall second?
We can.
Can we do like 28?
28 from the Wallops packet.
That one's it's like similar to the other one.
Yeah. So that's 1 over x root 4 squared. Is this the problem?
Yeah. Yeah.
Okay. Right, the bell's gonna ring in like a second, guys. Today's Tuesday. I recommend you come after school. You're gonna have like 20 minutes of homework from the book on area, and you're gonna have a lot of antiderivatives. You gotta like finish these packets.
Wait, like more?
No, just like
Oh, just-
I don't know. Probably just finish the packets. I think. Maybe more than that. I think I already signed. I don't know. All right. What are x root 4 squared minus 1? How do we do this? What should we do? I know what to do. Using I look at this and I feel like it's an arcsecant-ish. What is arcsecant? Arcsecant is zomp x root x squared minus 1. And so therefore what I'm going to do is I'm going to write this as dx over x root, and I'm going to think of this as 2x squared minus 1. And then I kind of want that to be a 2, right?
Yeah.
So I'm going to make that a 2x. But I'm also going to make that a 2 also, because I'm going to let u be 2x, and du is thus 2dx. And so this converts nicely into u over u root u squared, no, du over u root u squared minus 1. So it's just arcsecant u. It's actually arcsecant absolute value u for like obscure reasons. Arcsecant absolute value 2x. Let's see, bam. Who's with me? Mostly, good. Okay, I'm gonna stop there. Rune, thank you. Did the battery die?
No, it's still alive.
Okay, good. Turn that off.